These notes are section 3.2, and we're dealing with synthetic division. Now, what we're going to do is we're going to take a polynomial and divide it by another polynomial. In this case, a quadratic divided by a binomial, a linear binomial. Okay. So let's review. So synthetic is going to be a quicker way of dividing. So let's kind of do the old way of long dividing first, and then we'll show you how to do this exact same problem over here using something that we call synthetic division. So it's just a quicker way of doing sort of the same thing. All right, so remember, when we divide, we are going to take and put the x minus 4 out here. And then we put the polynomial. Remember, it's got to be in descending order. Remember, if there's any terms missing, we put them in. So degree 2, degree 1, degree 0. There's nothing missing, so we're good. We just write it out as it is. So we have 3x squared plus 10x plus 40. Okay. So then remember, we say to ourselves, what times x? Look at the first term and the first term. So what times x gives me 3x squared, and that's 3x. So we put that above, and then we multiply this 3x by both of these things and put the results under both of these terms. So we multiply 3x times x, that's 3x squared. 3x times negative 4, negative 12x. And then we subtract. But rather than subtract, we're going to add the opposites, because that way we don't make a mistake. We will sometimes make a mistake if we try subtracting positives and negative numbers. We always want to add. So in this case, we get 22x. You know, this is going to cancel, always does. And then we bring down the next term. So plus 40, we're always making that into an expression. So we got to put the plus 40 in. And then we ask ourselves again, what times x gives me 22x? Well, that's 22. So again, we're making an expression up here. So we got to put the plus or the minus, whatever it is. So that's a plus. And now I multiply. I get 22x. 22 times negative 4 is negative 88. And I subtract, only rather than subtract, again, we're going to add the opposites. And so when we add those up, we get 128. And so we're basically done. What do we do with this number down here? We say the answer is 3x plus 22 plus 128 over the divisor, x minus 4. Okay, so the answer is basically all of this. Okay. All right, so now let's talk about doing the same thing with a shorter, quicker way called synthetic division. Now, a couple things about synthetic division. You have to, when you're dividing, to use synthetic division, this has to be a linear binomial. So in other words, I could not divide by, say, x squared plus 2, because that's not a linear binomial. It is a quadratic binomial. All right, so it's got to be a binomial, but a linear, meaning this degree has got to be a 1. Okay, and then also, in order to do this, the leading coefficient of the thing you're dividing by, that linear coefficient has got to be a 1. All right, so I could not divide by 3x plus 1. Now you could, you have to make some modifications to the problem, but generally, synthetic division, the coefficient in front of this x has got to be a 1. The exponent also has to be a 1. Okay, so what we do first, it's just a kind of a very shorthand way of doing this. So we take the opposite of this term. So the constant in the linear term that we're dividing by. So we take minus 4, we take the opposite of that, and we put it in a little box right here. We make like a little L, a little box, half a box, I guess. Next to that, we are going to put this, but we're not going to put the whole thing. We only put the coefficients, well, and the constant. So we have 3, 10, and 40. Then we leave a space because there's going to be numbers. We draw a line underneath it. We're going to put numbers in here, so leave a space. Put a line here, and then put a vertical line between these last two numbers. All right. So this in here will end up being our remainder. Okay, so let's do it. So what I'm going to do, so this 3, this 10, and this 40 represent the 3, the 10, and the 40 in that expression. And we know this is the constant, so that's got to be the coefficient of x. This has got to be the coefficient of x squared. If there was a cube, there'd be another number, and that number would be one more degree higher, so it would be the coefficient of x cubed. Okay, so what we do is we simply, to start, bring down that coefficient. Now notice, we started here with a 3. We divide by 1x minus 4. Not a coincidence that our answer had the same coefficient as the thing we were dividing into. Okay, so we bring that 3 down. That goes here. Now, what these numbers are going to be, they are our answer. Okay, so you can see 3. That 3 is this 3. Okay, so I'm going to multiply these two together. 4 times 3, that's 12. Notice that represents this 10 and this 12. Now, normally we subtract, but instead of subtract, we add the opposites. But what I multiplied that 3 by is already the opposite, because remember, this was -4, so now it's +4. So this is already the opposites. We don't have to subtract, we can add. So that's 22. That 22 is this 22, but that 22, because we're dividing by a 1 here, 1x, that's going to be the same thing as this. So that 22 here is this 22 in our answer. Okay, now I multiply again. That gave me 88. Again, I don't have to now do the opposite because I multiplied by 4, which is already the opposite. Okay, I add, that's 128. Now, you might say, well, that didn't take any less time. Well, I mean, because I'm explaining everything. But yes, this is much quicker than doing all of this. Okay, and so what's our answer? So this isn't our answer. We then have to take this and rewrite it. So our answer is 3x. Now I know we started with x squared. We're dividing by x to the 1 power. I know this coefficient is going to be the coefficient of x to 1 power less than what I started with, because I'm dividing by x to the 1. And indeed, we can't use anything but x to the 1. Can't use a binomial that's a quadratic. All right. Or we could start with the 22. This is always the constant. So I could have started with 22 plus and then work backwards. This is the coefficient of the next highest degree term. So 22 and then 3 to the x. So constant 22, 3x. All right. And then again, plus 128 divided by, not by 4, but by what we were originally dividing by, x minus 4. Okay, and you can see you get the same answer. Okay, when we divide a polynomial by this binomial, the resulting polynomial, which is this one here, is referred to as the depressed polynomial. Depressed, I mean, think about it. Oh, you're down, right? You go down 1. So the degree was 2. This is the depressed polynomial. Its degree is 1 less. So that's degree of 1. All right. Now, if we were to divide 29 by 3, we would get the remainder of 7. I'm sorry, we would get 7 with a remainder of 2. So we could write this as 29 is equal to 3 times 7 plus 2. All right. Now, what they sometimes want us to do is do a similar thing, right? So you start it with 29. So if I took 29 and I divided it by 3, right? That would be 3 goes into 29. That's not right. It's not 3. 29 divided by 3 is 9, right? I think there's a typo there. 9 times 3 is 27. So those should both be 9s. Actually, that's a typo in there. When we divide 29 by 3, we get 9, and we would multiply, get 27, and we would subtract and get 2, so we would have a remainder of 2. So we could write, instead of sort of doing this, we could take our results and say 29 is the same as 3 times 9 plus 2, okay? And so they want us to do a similar thing, and your homework is going to ask you to do a similar thing. Take the original thing that we were dividing by, which is this polynomial, and write that in this using the same idea, right? So we divided by 3. So what did we divide by? We divided by x minus 4. And then what was the answer? The answer, essentially on top here, that was 3x plus 22. 22. And then plus the remainder, which was 2. In our case, it was 128. So 128. So the book is sort of asking us to take that division and sort of write it in this form. So some of your homework will be asking you to do that. Okay, so that way I just did an example so that you can look at that. So if you're confused at the homework, come back and look here at this kind of thing. Okay, so what we were dividing by times what that's the depressed polynomial, that's that part here, and then plus the remainder. All right. All right, so use synthetic division to divide this polynomial by x minus 3. And then we'll take our answer and we'll write it in that same kind of form after we're finished. Okay. So to start with, I want to make a box dividing by x minus 3. So what goes in the box? Positive 3. And now make sure you're in descending order. And be really careful when you're doing synthetic division. If, I always say, when you're doing here, if you have a missing term, put it in, right? 0x if there's no x term. It's really important that you do it here because you don't even have the variables next to these things. So you'll be putting things next to each other that don't even have the same degree. Like for example, here I know I'm doing this right because they both have the same. They have x to the 1, x to the 1, x squared, x squared. But without the number, without the variables next to it, just the coefficients, then you don't even sure that these things have the same type of variable next to them. So make sure, it's really important that if you have any missing terms, you put the zeros in. So degree 3, well, that means it should have 4 terms, right? 4 terms. Degree 3, degree 2, degree 1, and the 0, which is the constant. So if it starts with a degree 3, make sure that you have 4 terms, and we do. Okay, so next to that 3, what are we putting? We're going to put a 4. Then we want to put negative 15. So you don't have to put the pluses in, but you definitely got to put the negatives in, right? Because now it's, instead of subtracting 15, it's really a negative 15. So we think of this as, this. Put a negative, sorry, that doesn't really look like a negative. Turn it into a plus and make that subtraction a negative next to that 15. So include it here. All right, and then we have 11. And then we have negative 10. All right, so I leave a space for numbers underneath those numbers, draw a horizontal line, draw this down. And again, this is where our remainder is going to be when we're done. Okay. So again, bring down the 4. So the 4 goes here, multiply, that's 12. Add, that's negative 3. Multiply, that's negative 9. It goes here. Multiply the 3 times the negative 3. That gives me negative 9. I add, that's 2. I multiply 3 times 2. That is 6. And I add, so it's negative 4. So now take this and write using this kind of format, right? What we divided by, the original, the depressed polynomial, and the remainder. So that would be 4x cubed minus 15x squared plus 11x minus 10 is equal to x minus 3 times this depressed polynomial. Now, let's write what it is. So if you want to think, this is the constant, this is the coefficient of the x term, this is the coefficient of the x squared term. Remember, it started as a cube. Our depressed polynomial will be degree 2. So 4x squared minus 3x plus 2, and then plus, oops, I'm running out of space there, plus, well, actually, let's do it, just subtract. You could do plus a negative, or subtract 4. Okay? So that's what they're asking for. Take the original problem and write it in this format. They're going to ask you for that for your homework. Okay. So also another couple ways that they could ask you. They could show you a polynomial, divide it by this binomial, or they could show you that same polynomial times that binomial to the -1 power. Remember that -1 means we're going to flip it and put it down below. So we could write it either way. You'll see some problems written this way. You'll see some problems written as this kind of big fraction. Okay. Either way, do the problem in the same format. All right. So let's set that up. I'm going to make a box. What goes next? What goes in that box? +2. And then put in the numbers next to this. Let's see what you do. All right, so we have a 5 for the 5x cubed minus a 6 minus a 3 for the x squared, for the 3x, minus 3x. And then I'm going to put a 0 in there for the missing term, okay, because the constant is missing. So I would put that in there and then draw my horizontal line, vertical one between those last two numbers. All right, so I'm going to bring down my 5. Feel free to pause this video and try it on your own, and then unpause it to see if you did it correctly. I'm going to multiply. That gives me a 10. I'm going to add. That's a 4. Going to multiply. That gives me 8. I'm going to add. That gives me 5. I'm going to multiply. That gives me 10. And so my remainder is 10. All right, so let's write this again in the format that they're asking us to write. Well, it doesn't say specifically for this one to write it in that format. So what's the answer? If you want to think of it that, let's write up here. So this is 5x. Now, what power is that going to be to this 5? We start with a cube. So this has got to be 1 less squared because we divide it by x to the 1. So it decreases by 1, the depressed polynomial. All right, so we have 5x squared plus 4x plus 5, and then plus 10 over what we were dividing by, x minus 2. So if they tell us to write it in this format, then do that. Go back and sort of rewrite it, the divisor times the depressed polynomial plus the remainder. But if they don't, and they just ask us to simplify this, then write this as your answer. Okay. All right, let's try the next one. And again, pause the video for number 5 so you can try it on your own, and then watch the video to see how you did. Okay, so I'm going to go ahead and assume you've done it. So I'm going to put a 1 in the box, the opposite here. And then next to that goes a 1 for the 4x, x to the 4th. And then there's the cube term that's missing. So I'm going to put a 0 in for the x cubed term. I'm going to put for the squared -2, -5, 3. Put a horizontal line in there and a vertical line underneath and between the last two numbers. All right, bring down the 1. And now we multiply. That's 1. We add. That's 1. We multiply. That's 1. We add. That's -1. We multiply, that's a -1. We add, that's -6. And then we multiply, it's a -6. And we add, that's -3. Okay. Now let's write that answer. So think about what this is coefficient of. So we have, don't have to put a 1, but I'm just going to do it to emphasize 1 x to the what? Third, because we started with the degree 4, this should be 1 less. Or you could start with a constant. This is x, the coefficient for x squared, coefficient for x cubed. So either way you want to do it, plus x squared minus x minus 6, and then plus -3 divided by x minus 1. Or we could write this as what? Minus a +3, right? So either way, you know, you plus a -3 over this or minus the fraction. Either way you want to do it. Okay. Now, let's look at number 6. They give us a function. Again, it happens to be the same function. You'll see why in a minute. And they're asking us to find f of 1. So evaluate this function. Find f of 1. So we're just going to put in, so f of 1, we're just going to put a 1 in for x. So that's going to be 1 to the 4th power, that's 1. Minus 2 times 1. And then minus 5 times 1. And then plus 3. Okay. So what does that give us? That gives us -6. That gives us -3. Now, it's not a coincidence that those two things are the same. And that's sort of what we're looking at in the next, the theorem on the next page, sort of the introduction to that idea. Okay. So notice that this one and this one are the same. And so if those are the same, and of course we're using the same problem, the same polynomial that we're dividing into, then our remainder will be the same as this value when we evaluate the function evaluated at that same x value. All right, so let's look then at that remainder theorem, which is on the next page. All right, so if a polynomial f of x is divided by some binomial, so in that last example, the binomial we divided by was x minus 1. So k was 1. All right, then the remainder will be equal to f of k. So the k that we're using is it was the opposite of this, right? You get rid of that negative. So in our case, we divided, in that last problem, we divided by 1. Well, in the box was 1, right? So, and then f of 1 gave us the same value as the remainder when we divided. Okay, so let's look at, you know, an example of this. If we take this thing, then let's use the remainder theorem to find f of 4. Now, what they're saying is, I could put a 4 in this. That would be kind of annoying. But what they're asking us to do instead is to use the remainder theorem. So that means divide. So what would we divide by? Divide this polynomial by x minus 4, right? So in the box, I put a positive 4. All right, it's going to be the same as the function, the value that we're evaluating, the x value that we're evaluating the function at. All right, so let's put all these things in. So we have -3, we have 15, we don't have, let's stop for a second, make sure we don't have any missing terms. Degree 4 means we should have 5 terms. 1, 2, 3, 4, 5. Good check, quick check to see that we don't have any missing terms. And make sure they're in descending order. Sometimes they mix them up on us. Make sure the degrees are descending order. -50 and 25. Okay, 1, 2, 3, 4, 5. Let's put our horizontal line in and draw in a vertical line. So this value, whatever it is going to be equal to f of 4 okay? And so let's do that. Bring down the negative 3. I multiply, that's negative 12. I add, that's 3. I multiply, that's 12. I add, that's negative 3. I multiply, that's negative 12. I add, that's negative 62. I multiply negative 62 times 4, negative 248. All right, when I add that, I get, sorry, this kind of circle is sort of in the way. I add these up, and I get negative 223. So that means f of 4 equals negative 223. And so I think that would probably even be faster to do it this way than to plug in a 4, right? What's 4 to the 4th? What's 4 to the 3rd? And multiply all those together. This is actually faster, right? If it was asking you to do f of 0, well, probably no, then plugging it in would be faster. That's clearly going to be 25. You know, that kind of thing. So sometimes, like if it was f of 1, right, plugging a 1 into these is pretty easy. But something like 4, it's actually quicker to use the remainder theorem for that. Okay. Number 8, divide 203 by 7. What's the remainder? And what does this mean about the relationship between 203 and 7? So let's do long division. So number 8, we're asked to divide 203 by 7. Let's do that. So we're going to use long division, essentially. So 7 goes into 203. So 7 does not go into 2, but 7 goes into 20 2 times. And then 2 times. And so we multiply, that's 14. And we subtract, that's 6, and we bring down the 3. 7 goes into 63 9 times. And when you multiply that 63, there's not much space there, but you can see that the remainder is 0. Okay, so what does that mean? That's what they're asking. What does that mean about the relationship of 203 and 7? Well, that means that 7 is a factor of 203. So I could take 203 and write it as 7 times 29. Okay? And so a big part of what we do in Algebra 2 is we try to factor polynomials. Now, we don't generally know how to factor, we know how to factor quadratics, some cubics, differences of cubes, sums of cubes. We know how to factor some of those. And some special quartics, degree 4. Some we know, but generally we don't know how to factor these. But if we take a polynomial and divide it by a binomial, and the remainder is 0, that means this is a factor of the original problem. Okay, so let's go ahead and divide. Using synthetic division, what goes in the box when we divide these? All right, in this case, negative 2, the opposite of this value in here. Okay, so we have, next to that is going to be a 1. We have a missing term, right? There's no cubic, so make sure you put a 0 in for the x cubed. Then we have a negative 2. So let's think about this. With degree 4, we should have 1, 2, 3, 4. We should have 5 terms, so we're only missing 1. So that was the only one that's missing. 3 for the 3x, and then negative 2. Okay, so leave a space for some numbers. Draw in your horizontal line, vertical line between the two. All right, bring down the 1. Multiply, that's negative 2. Add, that'll be negative 2. Multiply, that's 4. Add, that's 2. Multiply, that's negative 4. Add, that'll be negative 1. When we multiply those two together, we get a 2, and we get a remainder of 0. All right, so just like we saw up here when we had a remainder of 0, these two things were factors of 203. So now the same kind of thing, the depressed polynomial, sort of the answer, right, and the original binomial are both factors. So that means that's kind of what this is saying here. Note that x equals -2. No, that's this example here for a sec. Just hang on for just a second. Let's finish this. So that means I could take the original polynomial, x to the fourth minus 2x squared plus 3x minus 2, and I could factor it. So I know that it is going to be x plus 2 times, well, the remaining, the actual polynomial, what this would be. So remember, this will be x cubed minus 2x squared plus 2x minus 1. So we've taken this quartic degree 4 polynomial and we've factored it. Now, we could, we've never been able to do something like this. And so knowing that the remainder is 0 tells us that that binomial is a factor of the polynomial we were dividing. Okay. Now, what we've done here is we have graphed this thing. We've graphed this function, and it's over here. And so let's think about this. Note that in this graph, x equals -2 is a 0 of that function. A 0 is just, if I set this function equal to 0, I could graph it, and where it crosses the x-axis are going to be my solutions to this equation. So if this is the equation I'm looking to solve, I'm looking for zeros, and those zeros are where this function is equal to 0. Remember, this is like y, f of x is y, so where is the y equal to 0, what we're doing here? And so y is equal to 0 on the x-axis. So I know from the graph that one of my solutions is x equals -2. Because x plus 2 is a factor of that polynomial, right? We know that that's the case. So in other words, remember, if we were to set this thing equal to 0, we would say, okay, where are the solutions? Well, set this equal to 0, so x equals -2. So it's not a coincidence that the graph goes through the x-axis at -2. We would set this equal to 0 as well. Maybe we could factor this using grouping or some other way. We might be able to factor this further. Okay, but we can kind of see what the next solution is as well. So using the graph of f of x, find another 0 of this polynomial. Well, we can see here, this is another 0. X equals 1 is another 0. And so we could say, okay, so x equals 1 is a 0. What would be the binomial? So like we're like, oh, we know that if we wanted to factor this further, we know this would be x what? If x equals 1 is a 0, then the binomial would be x plus 1, right? So like, for example, here, this was x equals -2. The binomial is x plus 2. All right, does that make sense? So that means the binomial here will be x minus 1. All right. So let's take this polynomial, the depressed polynomial from the previous part of the problem, and let's try to factor it by finding its zeros, right? Now we know this is a 0 of the original thing, so we know that x minus 1 will be a factor in there. So let's use our synthetic division, and we put a 1 in here, and then next to that comes a 1, and oh wait, sorry, we don't. My bad. We don't want to go back to this original one. What we want to use is the depressed polynomial from up above. We want to use these numbers up here. So we're going to do 1, -2, 2, -1. And again, leave a space for numbers, draw a vertical line between them. So we bring down the 1, multiply, that's 1. We add, that's -1. We multiply, that's -1. we add, that's a 1, we multiply, that's a 1, and the remainder is 0. So now we've taken this part and we've broken it down into the binomial and the depressed polynomial as a result. So let's kind of rewrite what we have so far. So we have the original thing, x to the 4th minus 2x squared plus 3x minus 2. We've broken that down into x plus 2 times the original depressed polynomial, x cubed minus 2x squared plus 2x minus 1. And now we've taken this and we've broken it down again. So we still have the x plus 2 here. And we've broken this part. We've essentially done synthetic division on it again, using these two zeros sort of helps us. We had one here. The other one's got to be there too. So we have x minus 1. And then this rest is the depressed polynomial, x squared minus x plus 1. Okay, now this is a quadratic. We know how to factor quadratics if it were factorable, and indeed this one is not factorable. But if this quadratic was factorable, we would see that, and we would be able to factor that again. But also, if this was factorable, this quadratic trinomial was factorable, you would see more zeros up here, right? So I know that if we were going to use if we were going to try to factor this further, it would not factor. We might have to use quadratic formula if we're looking for actual zeros. So here we're just factoring. We're not looking for zeros, but we know, like, okay, we could turn this into x equals negative 2, x equals 1, and we could use the quadratic formula on this. If we were looking for actual zeros, we would have to then apply quadratic formula to this because it would not factor. But in this case, we're not really looking for the solutions or the zeros. Instead, we're looking for factoring. And so we've taken, now this is pretty phenomenal when you think about it. We've taken a quartic problem that there's no way we could factor, and we factored it. All right, so pretty amazing. We haven't done that yet. We've never had to, and so by looking for, and in this case, it helps because we kind of knew what zeros were and what the resulting binomials would be. So we divided it by 1 here, x plus 2, and then we divided by x minus 1 and chipped away at this thing, starting with the degree 4, then got a depressed polynomial of degree 3, and then now we have a depressed polynomial of degree 2. Okay, so determine whether the given k is a 0. So is k a 0? So if it is, so that means we would say, oh, x equals 2 would be a solution or a 0 to this polynomial. And so if that's the case, what binomial would we use? We would use x minus 2 as the binomial. So what we want to do is divide, but we're going to divide by this. So as it turns out, the potential 0 is what goes in the box. So if I'm dividing, I would put a positive 2 in that. So I just wanted to make sure that you understand that if we're checking to see if x equals 2 is a solution, then, or a 0, then, or where the function would cross the x-axis, then we would be dividing by x minus 2. Okay, and so, but again, then we switch the sign again and make it a 2. So what goes in this box in synthetic division is the potential 0 or solution to that. Okay, so next to that, let's double check. We have degree 3, so we should have 4 terms, 1, 2, 3. All right, we're missing 1, so be careful. Figure out where that is. We have a 2. We have a negative 3. We have a 0 because the x term is missing, and then minus 18. All right, and so leave a space for numbers underneath those and draw in vertical line there. All right, so we bring down the 2. Multiply, that's 4. Add, that's 1. Multiply, we put a 2. Add, that's a 2. Multiply, that's a 4. So clearly this is negative 14. This is not a 0. If this had been a 0, then that means a value of 2 would be a 0. That means if we graph this function, it should cross the x-axis at 2. This is a no. All right. X equals 2 is not a 0. Okay. All right. Try B then. So what goes in the box? The actual potential 0, -3. Remember, if we're thinking of it as a factor or a binomial, it would be x plus 3. Okay. What goes next to that? Okay, degree 4. Are there any missing terms? 1, 2, 3, 4, 5. 5 terms is what we expect. They all seem to be there. So 1, -4, -14, 36, 45. Draw your line, and then your vertical. All right, bring down the 1. Sorry, that's a 1. And then multiply, that's -3. Add, that's -7. Multiply, that's 21. Add, that's 7. Multiply, that's -21. Add, that's 15. We multiply, -45. And so the remainder is 0. So that is a 0 this time. So yes, that works. Because a remainder of 0, we could take this and factor it into x plus 3 times the depressed polynomial. So that would be x cubed minus 7x squared plus 7x. Sorry, I used up a little bit of space there. 7x plus 15. So we've taken, we could, in theory, that's not really what they're asking here, but we could take this and we know, since its remainder is 0, that what we were dividing by is a factor. So we could take that quartic and factor it. Now, I don't think we could factor this any further, but if we, looked for some more zeros, some other things that gave us remainders of 0, we will be able to possibly factor that further, and we'll see that in future sections. Okay. All right, and then this last one. All right, so be careful with this one. This one's a little tricky. So zeros are sort of solutions, right? So for example, we had 2 solutions here. We had a -2 and we had a 1. Our zeros or solutions if we took this original thing and set it equal to 0. Now we know this is the degree 4, so it should have 4 solutions. Only 2 of them are real. There will be 2 more that are imaginary. So this thing has a degree 4. There's got an extra little squiggle in it. Those squiggles, if you remember, take up another pair of solutions. So that's what we're asking. Look for here is one of these solutions imaginary? So this is an imaginary potential answer. So what we want to do is we want to put that into the box. So we have 1 plus 3i goes in the box. All right, so this one's going to be a little different, but let's work with it. It takes a little bit of extra work to kind of look at this and try. So just bear with me here. Let's double check to make sure we don't have any missing terms. With degree 4, so we have 1, 2, 3, 4, 5 terms. So it looks like we've got everything we need. Let's put those numbers in 1. Let's space them out a little bit for this one because you'll see why in a minute. Space them out a little bit more than usual with these with the complex, because this is it's a number, but it looks more like a binomial. It's a little bit wider, so we need a little more space. All right, 14, and then -28, -20. Sorry, -20. All right, so we're going to leave some space. Draw in your vertical line. Okay, so bring down the 1, and then I multiply. So when I put it here, I end up with 1 plus 3i. All right, when I add these, I got to add the real parts and the imaginary. Well, there's no imaginary parts of this. It's just -1 plus this 1. So that cancels, and that just leaves us with 3i. I now multiply. When I multiply this number by this binomial, it's not really a binomial, it's a complex number, but it acts like a binomial. So we're going to multiply 1 by 3i, that will be 3i. And then when I multiply the 3i and the 3i, that's 9i squared, which is -9. So we have -9 plus 3i. Now when I add this, I get -3 plus 3i. Okay, now when I multiply these together, it's getting a little complicated. When I multiply these together, I'm going to do that kind of on the side here. That means I'm going to have 1 plus 3i times -3 plus 3i. And we're going to treat that like a binomial, like you're foiling two binomials. So that's going to give us the outer, -3, the first, sorry, -3, the outer is plus 3i, the inner -9i, and the last together, and that's 9i squared, so -9. All right. And so let's put the real parts together. So that's going to be -12. So let's write -12. And then the imaginary parts, that's going to be -6. So -12 minus 6i. Let's add these. That's going to give us 2 minus 6i. And again, we need to multiply those together again. So another pair of binomial-ish type thing. So 1 plus 3i times 2 minus 6i. And when I multiply those, I get what? 2 minus 6i, the outer. The inner is plus 6i. And then the last give us -18i squared, so plus 18. Okay. So this should look good because, you know, these, of course, are going to cancel. And so this gives us 20. Okay. So that was kind of a lot of work here, but 20, we add, we get 0. So what does that tell us? It tells us that this is indeed a 0 of the polynomial. All right. So yes, 1 plus 3i is a 0. Now, when we say a 0, normally we think of a 0 as something that where it crosses the x-axis, but of course this is complex. So the 0 really means that it is a solution. If we took that function, instead of making it a function, and we set it equal to 0, and so we know that 1 plus 3i would end up being one of our solutions. So zeros, solutions, same sort of terminology, same synonymous terms. But here we think about, you know, makes sense here when we say -3 is a 0. That means if we took this function up here and graphed it, we know it crosses the x-axis over here at -3, right? But here we can't graph 1 plus 3i. So yes, it's a 0, but really think of it more as a solution if we set the function equal to 0. That makes probably more sense than trying to say, oh, the 0, where does this cross the x-axis? It doesn't. Complex zeros or complex solutions cannot be gotten by graphing. Whereas up here we saw that we see that these are solutions to this equation being set equal to 0. Those are the real solutions or real zeros. Okay. All right. So your homework due next class is this.